Hello, welcome back to another video lecture on basic algebra. Today we're going to be talking about exponential functions. So generally, exponentials are in the form of y equals a times b to the x. So if x equals 0, then y equals a times b to the 0. So b is just equal to 1 because anything to the power of 1 is 0, which means a is going to be what your starting value is. So y equals a when x is 0, so a is the starting value. If b is between 0 and 1, then you're going to decay. You have what's known as exponential decay. If b is greater than 1, then the function is going to grow. We have what's known as exponential growth. And if b equals 1, then we simply have y equals a, which is just a simple horizontal line. Here we have a few examples of kind of generally what these graphs will look like. So when b is greater than 1, you can see that it's going to kind of steadily increase more and more and more. And then when b is less than 1 but greater than 0, we have that it just continuously decreases until it slows down the decrease here. If b was equal to 0, then the whole thing would be 0. You would just have y equals a times 0, which equals 0. So you just end up with a horizontal line which equals 0. And when b is negative, well, things get rather interesting, kind of dots up and down across the graph. So we're not going to be discussing the situations other than these two, when 0 is less than b is less than 1, and when b is greater than 1. So those are the only two situations that we're really going to consider. So let's look at some examples and work out some problems involving exponentials. Here we have an example. It says complete the table for y equals 2x and then graph. So we're going to start here. We can see that we can do the easiest ones first, which are our positive numbers. When x equals 0, we just have 2 to the power of 0, which just equals 1. When x is 1, we get 2 to the power of 1, which is 2. And when x equals 2, we get 2 to the power of 2, which is 4. So let's talk about these negative ones. So when x is negative 1, we get y equals 2 to the negative 1. This is 1 over 2. Then when we get negative 2, 2 to the power of negative 2, we get 1 over 2 squared, which is 1 over 4. So you've got to remember your rules for exponents when you're working with these. Remember that when you have a negative exponent, you're just bringing down the number here and bringing the power up on the bottom. So we're doing it like this. Here we have a negative 2, so we bring the 2 down, and the 2 becomes positive on the bottom. So the other part of this says to graph. So I've got a little bit of a graph here, just waiting for us to start it. So it says that we have the point 0, 1, so we're going to start there with our starting point of 0, 1 here. And then we have the point 1, 2, and then the point 2, 4. Then we had 1/2, and then a fourth. And you could see that it's going to kind of follow this line. This would be... It's going to kind of go up like this. And we're going to end up getting something that kind of looks like that. So let's do another one of these complete the table examples. Here I've got y equals 6 times 1.2 to the power of x. So once again, a is our starting value, so this is going to be 6. But this is where things get a little bit harder. So first, when x is 1, we get 6 times 1.2, which is 7.2. So 6 times 1.2 equals 7.2. So we got 7.2 here. And then when we have this power of 2, this is 6 times 1.2 squared. So 1.2 squared, this is 1.44 times 6. So 1.2 squared is 1.44. And then we multiply that by 6, and we get 8.64. So let's look at our negatives over here. When x is negative 1, we get 6 times 1.2 to the power of negative 1. This is 6 divided by 1.2, which equals 5. So this is going to be 5. And then when we do the negative 2, this is 6 times 1.2 to the power of negative 2. This equals 6 over 1.2 squared, which is going to be 6 divided by 1.44. Which equals 4.1, we're going to go ahead and round this to 17. It's 4.16 repeating. We're going to go ahead and round it to 4.17. And we write here 4.17. And so we've completed our table. And that's all that the question asked for. Didn't ask us to graph, just to complete the table. And another thing that you might notice is that it grows faster over here, and it doesn't grow a whole lot over here. So here it increased by less than 1, here it increased by 1, here it increased by more than 1, and here it increased by more than 1 again, even more. This is an increase of 1, this is an increase of 1.2, this is an increase of another 1.44. So let's go ahead and look at one more of these, complete the tables. Here I've got y equals 2 times 1/2 x to the power of x. So when x is 0, once again we're at our starting point of 2. When x is 1, we've got 2 times 1/2, and this gives us 1. Here we've got 2 times 1/2 squared, which is 1/4. So this gives us 2 over 4, which tells us this is 1/2. Which equals 2 over 4, which is 1/2. So let's look at our negatives. This is 2 times 1/2 to the negative 1, which is 2 times 2, because we flip this. This gives us 4. Then over here, we get 2 times 1/2 to the negative 2. This is 2 times 2 squared, which is 4, and 2 times 4 is 8. Now you'll notice here that the decrease becomes more and more gradual as we go further along. Here we dropped by 4, here we dropped by 2, then we dropped by 1, then 1/2. And if we continued this, you'd see that the decrease gets less and less each time. We'd end up at 1/4, 1/8, so on and so forth, and eventually we'll never really get to 0. But that's not something we need to worry too much about right now. So let's look at some a little bit more difficult problems. These two problems that I'm going to be showing are where we write the equation given a little bit of information. So here we have the starting value is 12, and it grows at a rate of 12%. So we can start here with y equals 12 times b to the x. And we need to figure out what b is. We know a because that's our starting value. So to find our b, we look at this growth rate. So it says it grows rather than decays. So that means that we're going to increase it by more than 1 each time. And since we're going up 12%, which this means that we're multiplying by 112% each time. So all we did was we took our original 1 and then we added our growth rate to it. As a decimal, that gives us 1.12. So b is 1.12. So we'd end up with y equals 12 times 1.12 to the power of x. And that's our equation. So let's look at another one. Here we say that the starting value is 15 and it decays at a rate of 20%. So we can always start off with y equals 15 times b to the x. And we need to find b. Well, we have a decay. Keyword is decay, and it decays by 20%. So that means that we're losing 20% each time. So we're losing 20% each time. So we can notice that this is a loss of 20%. We've written equations like this before. And this tells us that since it's less than 1, because of our decay, we would take 1 minus this 20, and this leaves us at an 80% of what's remaining each time, or 0.8. So we say that b is 0.8. Then we get y equals 15 times 0.8 to the power of x. So you can notice that when we had our growth, we had a number greater than 1, and we had our decay, we have a number less than 1. So let's look at a bit more of a real-world example. So here we say, suppose a population's growth is modeled as y equals 1,000 times 1.2 to the x, where x is years after 2001. And what year is the population double that of 2001? So we're going to go ahead and write our equation again down here, just in our workspace. Y equals 1,000 times 1.2 to the x. And we're looking for when it doubles. So we want it for x. So find x, or approximately find x, when y equals 2,000. Because we're looking for a double population. So here, we can actually make this really, really simple. All we're doing is we're doubling our population. So we can simply find out when this equals 2. So this doubles when 1.2 to the power of x equals 2. So this makes things a lot easier. And so we can go ahead and just kind of make a little table and put some values in. So we know that when we're going to do this, we're going to go ahead and do 1.2 to the x. So we're making a little table here. When x is 0, we just get 1.2. Or we just get 1. I'm sorry. This is just 1. When x equals 1, this is 1.2. When x equals 2, then we have to square 1.2, which is 1.44. When x is 3, we take 1.2 to the power of 3, so 1.2 to the power of 3, and that gives us 1.728. Still not quite double, right? And we continue this pattern until we do get it to double. And here at 4, when x is 4, you get 1.2 to the power of 4, and this gives us 2.0736. And so we could say, we're going to go ahead and round to the nearest year. That's 4 years after 2001. So population is doubled in 2005. Really, what we could say is it's at the end of 2004, which is 3 years after the start of 2001. But we're going to go ahead and use this one and say that it's double in 2005. So we're going to look at one more example, and it's similar to the last one. So suppose that the concentration of an antiviral in the blood, or in the bloodstream, is modeled as y equals 6 times 0.8 to the power of x, with x being hours after dosing. So how many hours pass before the concentration is half the initial amount? So then we're going to round to the nearest hour. So similar to what we did before, we're looking for half. So all we need, even though we have this, our original equation is this, what we need is when 0.8 to the x equals 1/2. Is approximately. So we're going to do the same thing we did in the last one. We're going to go ahead and say x 0.8 to the power of x, 0, 1, 2, 3, 4, 5, and if we need to, we'll just go on past that. So at 0, obviously this is just going to be 1. At 1, it's going to be 0.8. At 2, this is 0.8 squared, which is 0.64. At 3, we get 0.8 cubed, which is going to be 0.512. And if we wanted to, let's look at how it is at 4. So 0.8 to the power of 4. And this is 4.4096. So we can see that after hour 3, we're the closest to 1/2. So we could say that about 3 hours after dosing. So this is generally about how you work with exponentials. I hope this has helped you learn more about how to work with exponential functions. Hope you enjoyed the video. Thank you for joining us, and I'll see you in the next. Goodbye.